In the TensorFlow course, you built and trained models layer by layer. You stacked the dense layers, you picked the optimizer, you watched the law scroll down over epochs, and only then did you have something that could make a prediction. That was the whole point, understanding every wire. But now I want to show you the other end of the spectrum. Here, the first model you ever run takes exactly one line of code. No layers, no training loop, no GPU build. Somebody already did the hard part. Hugging Face is the place where they left it for you, and today you just walk up and use it. So, what actually is Hugging Face? Picture an enormous public library, except instead of books on the shelves, there are trained models, hundreds of thousands of them. Someone trained a model to detect sentiment, someone else trained one to translate French, another to transcribe speech. They all uploaded their finished work to one place called the hub. You don't retrain any of it. You borrow it the same way you'd pull a book off a shelf, already written, already proofread, ready to read. Every model on that hub lives at an address, just like a username and a repo on GitHub. The default sentiment model we'll use is called Distilbert Base Uncased, fine-tuned SST to English. That's a mouthful, but read it backwards and it tells you its whole life story. It's English, it was fine-tuned on a dataset called SST2. It's uncased, and it's a smaller, faster cousin of BERT called Distilbert. The name is the receipt for everything that model already learned before you arrived. Now here's the trick that makes day one feel like magic: the pipeline. A pipeline is a single function that bundles three messy steps into one. It finds and downloads the model, it prepares your text so the model can read it, and it cleans up the model's raw output into something a human can understand. You hand it a string, it hands you back an answer. Everything ugly in between is hidden inside that one word. Let's talk about what a pipeline you can ask for. You give it a task name, a label for the kind of job you want done. Say sentiment analysis, and you get a model that decides if text is positive or negative. Say translation, summarization, question answering. There are dozens of these task strings, and each one quietly loads a sensible default model behind your back. Same one-line shape every time, only the task word changes. So what comes back? Not a wall of numbers, a clean little verdict. For our sentence, the pipeline returns a list holding one dictionary, and that dictionary has just two keys: a label, which here reads positive, and a score, which here is 0.99998. The label is the model's decision. The score is its confidence, a probability between 0 and 1. 0.9998 means the model is almost completely certain this sentence is happy. And that confidence number is honest about doubt too. Feed it something genuinely mixed. The food was great, but the weight was terrible. And the score sags toward the middle, maybe 0.6, because the model really isn't sure. A high score near 1 means I'd bet on this. A score near 0.5 means I'm basically flipping a coin. Reading that number is a real skill, and it's the first one this whole course teaches you. Don't just take the label, look at how sure the model is before you trust it. Alright, let's open the file. It's one short script, just a single page of code, and honestly most of it is comments and printing. There are only really 3 lines that do work, so I'll walk you through the file top to bottom and point out each one as it comes. First, the import. We pull pipeline straight off the transformers library. That's the one core function we need, so we import it by name and nothing else. One clean line at the top. If transformers is installed, this just works. That import is the entire setup ceremony for today. Next, we build the pipeline itself. We call pipeline and pass it the task string sentiment analysis, and we store the result in a variable called classifier. The very first time this runs, it quietly reaches out to the hub, downloads the default Distilbert sentiment model, and caches it on your machine so the next run is instant. After this single line, classifier is a fully loaded, ready-to-use model sitting in memory. Then comes the payoff. We hand our sentence, the string "I love this," straight into classifier, like calling any normal function, and we catch what comes back in a variable called result. That's it. That one call ran the text through the tokenizer, through the neural network, and back out through the cleanup step, all invisibly. Result now holds the model's verdict. Finally, we print the raw result so you can see its true shape, a list with one dictionary inside, label and score. Then, to be friendly, we reach into that dictionary, pull out the label and the score separately, and print one nicely formatted human sentence, rounding the confidence to 4 decimal places so it reads cleanly. 2 prints, one honest, one polished. And that's the whole thing. One import, one pipeline, one call, and a couple of prints standing between you and a working sentiment model. You ran a real neural network in a single line and read its confidence of the result. But notice what we skipped. That one friendly line quietly turned your sentence, actual letters and spaces, into numbers the model could math over, and then turned the answer back into words, and we never saw any of it. That conversion is the tokenizer, and it's the beating heart of every model on the hub. Next, we crack it open and watch your sentence become input IDs and an attention mask.